Alright, so I tried starting the Wiley homework number 9, and I started part 1, and I got the first part right, and after that it was like getting really hard, so I just tried putting in all the wrong answers so that it would give me the answer, and it's unlimited tries. So I'm just going to start with what I got right so far, and then maybe you guys can help. Alright, so let me just, and I wrote everything prior this time, so it's going to be easier. Alright, so it says, so given the following information, elucidate the structure of compounds A and B. So it says, both compounds are soluble in dilute aqueous, right? So let me just see what we have here. Right, so, right, we have compounds A and B. So they're both soluble in dilute HCl aqueous, right? Okay, and they have the same molecular formula. They have the same molecular formula. Alright, so then it gives us the mass spectrometry data for A first, right? And what does it say? So this is for compound A, right? And the mass spectrum, what do they say? The mass spectrum? The mass spectrometry. Okay, the mass spectrometry data, we have the M plus peak, which is 149. Now, that's just the most prominent peak, right? It's the base peak. I think they say it's the base peak, which doesn't mean that it is the most. Let's see what it says here for a second. It's the base peak, but I don't know if that's the molecular formula. Oh no, it says intensity 3. Oh, intensity 37.1 of base peak. So this is not the base peak. Oh, this is the molecular. Okay, so this is the molecular weight, right? 149. And its intensity is 37.1% of the base peak. Okay, again, I'm gonna like put this into the you'll be able to get this in the Facebook group. Alright, and then they have the M plus 1. So of course the weight there is 150, so there's an isotope, right? And its intensity of the base peak is 4.2%, right? Of base peak. Ugh. Alright, so then it says, so then it gives us the IR spectrum for A. And it tells us that, what is it? It says that there's 2 bands in the 3,300 to 3,500 centimeter or centimeters to the -1 power region. And then they give us the carbon-13 data, the DEPT data, which is a little confusing because, okay, the DEPT13 spectra is given in parentheses with the 13C chemical shift. So the DEPT13 carbon-13 data gives us the carbons, their chemical shifts, which tells us how close they are to electronegative atoms, right? And then also how many hydrogens they have attached to them. So the chemical shift, they have a chemical shift of 140, and that's just a C with no hydrogens, so that's closest to the electronegative atom. 127, that's another just carbon. 125, another just carbon, unless I'm crazy. Is there really three? No, that was carbon H, right? CH. Yes. There's a CH. No. 127, 125, yes, CH. This is CH. And then there was a 118. CH. A 24 CH, a 24 CH2, and then a 113 CH3. So that means the CH3 is far away from the electronegative atom, which is either oxygens or nitrogens. Okay. And these are close to oxygens or nitrogens. Alright, so then the question, these are the questions I got right so far. It says, alright, what is the molecular ion fragment? Okay, what does the molecular ion fragment suggest about nitrogen atoms? Since the molecular ion fragment is 49, that means that there's an odd number of nitrogens, right? And I got that from page 436, and that is the nitrogen rule. Okay. 436 in our textbook. If you're just watching this and you're not in our class, I'll post that information sometime in the future. Okay, so then the next question was solubility. The solubility in dilute aqueous HCl and the absorption bands between 3,300 and 3,500 centimeters to the -1 power suggests what? It suggests the presence of primary amines. Now, it also suggests, or from what it seems to me, I got this from, where did I get this from? I got this from page 86 in the book. It could be primary amines or secondary amines. I don't know why I would be able to tell. Oh, maybe our secondary amines. Okay, it said, oh, wait, what did I write and get right? Primary, right? Let's see. Primary, yeah. Maybe secondary amines are not soluble. Maybe, oh, I gotta look that up. Right, maybe secondary amines are not soluble. I don't know, this might cut me off in a second. So let's see. Let's see. So, and then the third part of the question I got right. So, the 13C NMR data provided. So, it suggested, right? What did it suggest? It suggested the presence of disubstituted benzene rings. And I got that from page, see if it's going to cut me off, but I think these are only 11 minutes long. Oh, okay, maybe YouTube gives you more time now. So page 418, table 9.2. So that absorption, I don't know if it's necessarily like dye substitute. I said it was dye substitute because I was trying to think of ways to make the formula work. The presence of. Alright, so then, now this is where I start messing up. So it said yes, benzene ring. It's a dye substituted benzene ring. And what else did it say? Dye substituted benzene ring. It has an odd number of nitrogens, so it has at least one, and they're primary. And then we have to get to the molecular formula. So I'll show you something that I'm a little confused about. And after this, I got everything wrong. So I have the, they gave us the M+1 peak, right? And they gave us its intensity. Now, according to the book on page 435 to 436, you take the M+1 intensity, which they gave as 4.2%, and you divide it by 1.1, which is the abundance of isotopic carbon isotope carbon-13. And when I get that, I get 4 carbons, right? But I thought that the molecular weight was going to be 149. So maybe I guess there's tons of nitrogens and oxygens in this. So, but then you can't have a benzene ring you can't have a benzene ring with 4 carbons. So maybe I'll send this video to Allison and see what she said, or if you guys can get back to me, that would be helpful. Thanks. And I'm just going to keep going.